कैसा चल रहा है पढ़ाई लिखाई? अच्छा चल रहा है।
हाँ सर।
और इस स्कूल में एग्जाम्स में रिजल्ट्स कैसे आ रहे हैं?
सर मुझे साइंस में मिला है आउट ऑफ 80 72 पर।
ओके गुड। और यूटी में कैसा कर रहे हो? ठीक है, टेस्ट दे रहे हो सारे ना?
ये संडे टेस्ट वर्क इन एनर्जी का।
अच्छा, सारे टेस्ट लिखते हो ना? So uses of multiple reflection of sound. क्या है इसमें? So सबसे पहला एप्लीकेशन है हमारा मेगाफोन, ट्रम्पेट, शहनाई, शहनाई, तो मेगाफोन क्या होता है? पब्लिक एड्रेसिंग के लिए जो चिल्लाते हैं ना मेगाफोन, तो मेगाफोन इज समथिंग लाइक दिस। मेगाफोन क्या करता है? अरे चिल्लाता है। है ना? If somebody shouts in front of the megaphone, वैसा हाथ में पकड़ के, ठीक है? So what happens? The sound falls on this surface. तो उसके बाद क्या होगा? रिफ्लेक्ट होगा। फिर क्या होगा? रिफ्लेक्ट होगा। सीधे जाएगा, है ना? तो मल्टीपल रिफ्लेक्शन हुआ, एक यहाँ पे हुआ, एक यहाँ पे। ऐसे ही साउंड तो हर डायरेक्शन में जा रहा है, ऐसे रिफ्लेक्ट होगा। ऐसे reflect होगा. मतलब once the megaphone is used, there are multiple reflections taking place at the interior of the megaphone, right? Similar thing happens in trumpet. So then sound can travel in a well-directed way for a longer distance due to this multiple reflections taking place inside the surface. Okay? Trumpet में भी वही होता है, ऐसे ही कुछ रहता है उसके अंदर. यहाँ से तुमने देखा होगा ये भी ऐसा कुछ रहता है ना, तो जो मल्टीपल रिफ्लेक्ट होके 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 ना बहुत दूर तक सीधा जाता है. सेम थिंग इन सैनाइट्स, ठीक है. This is how the multiple reflection takes place. Where else multiple reflection of sound takes place? Stethoscope. See how stethoscope में होता है. So suppose there's a patient so doctor places the stethoscope on the chest. So this picks up the sound. Right? So the doctor places it in its ear. Okay. So what happens is when the sound waves are picked, it vibrates the diaphragm of this probe or it picks up sound. Then it is reflected. Multiple reflections are. So it is likewise on the other surface, some sound will travel this side. So the sound waves are guided through the pipe, okay, with the help of multiple reflection by the surface, and which is the waves. So this is one. Okay, so this is the stethoscope, multiple reflection. Then ceilings of concert hall and cinema halls are curved. So, like you see the section of a hall, right? The stage is somewhere here, right? The performer is performing it. Or the movie is played here. So, for uniform sound distribution, right? And the rows, seating rows are like this. So, for equal sound to reach everywhere. Okay, one sound is reaching directly also. Okay. And then it is also reinforced from the top. So it reaches the audience uniform everywhere in the last. Also the wall, like sometimes the wall is made curved like this. The performer is performing here. Audiences are sitting here. Then sound travels in all directions, right? Reaches from behind also it will be here. From front, anyway it is going everywhere. But the wall is curved, like I am speaking, if this wall is curved, the sound will be well directed in front. So that's what is shown. That's the behind wall. So ceiling is also curved. The behind wall is also curved. In the halls you may see this. The screen is curved. Right? So observe it next time. So this is all about reflection of sound. And the next topic is range of hearing. Any questions? You just read reflection of sound, whatever is given. Any point if you don't understand. Uses of multiple reflection of sound. Just read that. Yes. You need any explanation? All clear. Okay. Let's go further. So next topic is range of hearing. So it can be categorized for humans. So audible range. For humans. What frequency we can hear? 20 hertz to 20 kilohertz or 20,000 hertz. Any sound within this frequency human can detect. Okay. So this is also called as sonic. Okay. This sound name is called sonic, which we can hear. The sound of less than 20 hertz is called infrasonic. Infrasonic waves. So this sound can be heard by bat, right? Elephants, whales, right? Certain types of fishes, rhinoceros, rhinos. So they can produce low frequency sound and listen also. Okay. So in case of elephants and whales, the sound for communication is infrasonic. Then you have frequency higher than 20,000 hertz. It is called ultrasound. Okay, it's one word, ultrasound. So the highest frequency sound wave is ultrasound waves. So it is most energetic. And well directed sound wave. Due to its high frequency and small wavelength. Certain ultrasound wave can travel for a long distance in a straight line, right? And since they are very energetic, they can travel for longer distances. Okay. So who can produce and hear ultrasound waves? So bats. Bats can produce ultrasound wave also. Dolphins, right? And it is some other applications like sonar applications. I'll tell you about it. With all this. Okay. So sonar stands for sound navigation and ranging. Sound navigation. And ranging. Okay. So sonar is used by sonar finds a lot of application in sonar used in used by sea sailors. Ships. These are the devices, right, used by sea sailing ships. Okay. So what is navigation? Navigation means traveling in a safe direction. Navigate safely means safe direction. And ranging means estimation of distance of obstacle. Okay. So we can use ultrasound waves to actually for navigation and ranging. So we can estimate the risk. For example, when a ship is sailing, let us say a ship is sailing and somewhere the captain feels that there is an iceberg. This is the tip of iceberg. Problem with icebergs are only a very little portion of a huge tip of iceberg is seen outside. More than 95% or 90% is inside. So if the captain keeps sailing the ship with slightly deviating the propeller, which is much below, right, much lower in the water, it may go and hit the iceberg. Correct? So the thing which the captain cannot see, what he can do? So every ship has a sonar equipment. So it has both the transmitter of ultrasound and receiver. So it will send ultrasound waves in all directions. Let us say it sends everywhere it will send. Because sound can travel in air, water, solid, everywhere, right? So wherever it is going, so from the reflecting surface, the sound will also come back. And in this device, in the sonar device, Here's a way to measure the time of reflected sound. Okay, and then there is an automatic program computer attached where the distance will be calculated. So we will know what is the distance. So he will take a decision whether it is a safe direction to travel or not. And he will change the direction. So this is ranging, calculation of distance of obstacle. And once he knows the distance, he already has the speed, etc. And he also will get the direction, right? Then he will change the course. Changing the direction is traveling in safe direction. Okay. So this is what sonar is used for. So in sonar, what waves we are using? We are using ultrasound waves. And we are using the method of echo. Reflected sound wave is analyzed to estimate this distance as well as the direction. Okay? So this is why the same technique can be used to measure the depth of the sea. Now it is this sonar devices directing the beams down. Okay, so you can direct. That is up to you where you want to use the sonar. So again you can calculate T equal to V into T1. For T you can measure. So you can calculate the depth of the sea. Right? These are the sonar applications. A bat also, let us say a bat is flying. Let us say a bat is flying in this direction. Right? And bat cannot see. Okay? Let us say there is a target also. And there is some cliff. Bat cannot see. So bat will send, it can produce and send UV rays no, ultrasound waves in all directions. Okay. So when the reflected wave comes back, bat has the ability to analyze or gather the nature of obstacle from the reflected sound wave. So he can decide, okay, this is the prey. Okay, I can go and hunt it. And this is not safe to fly. It will change course. So bat cannot see actually. So they make judgment basis the reflected ultrasound wave. Okay? So they are producing ultrasound wave through their vocal cord or whatever, or by flipping the wings. Okay? So this is what it is. Likewise, dolphins, they also produce, communicate, navigate, okay? Distance, navigation and ranging. They use the same technique for themselves to find the prey as well as to navigate safely. Okay, now since ultrasound wave is the most energetic wave and it can travel large distances in the medium, therefore it finds many other applications also. Right? So what are the applications? So what I suggest is you read the uses of ultrasound and then we can discuss. Range of hearing is completed. Now you use the uses of ultrasound. So one we have already covered, sonar uses. So when they find their prey, this is the second application. Okay. Bat and dolphin find, use it for navigation and drilling. Okay. So it has application in cleaning of machine parts. Let us understand how it is used, cleaning of machine parts. So what is done here? So what you do is you have a cleaning solution, right? You have a cleaning solution. So this could be some soap solution or whatever. Okay, cleaning solution. And then you soak in it some small components, electronic components, things like this. These are very, very small components. Okay. So you have now it is very delicate. So what you do is you now direct ultrasound waves in this. Ultrasound. So we may have like some devices which can electrically, you give current to it and it will produce ultrasound, right? There are electrical oscillators which can produce ultrasound. So when it is directed in the solution, it will just shake it. Okay? So all the dirt will be detached. Yet it will shake it like this. So that like a wind is blowing. Okay, but this is not, you can't see it, nor can you hear it. It will only produce the effect inside. Okay, so there will be shaking happening and the things will be cleaned. So these are small electronic machine parts. Like watch. When you open the watch, there will be hundreds of small components in the watch. Okay, so those things are very delicate. So if you go to clean it, you might deform it and affect the function. So this is pretty safe. Then you can weld plastic. Two plastic can be welded with the help of ultrasound wave. It is also used in the industries to detect flaws in welding or some cavities in metal blocks. So some industrial applications. Applications of ultrasound waves. Okay, so you can broadly categorize in two parts, or three parts: sonar application by animals as well as the sailors, then cleaning of machine parts, industrial way to identify cracks in welding or cavity inside metal blocks. Say in the construction of building and bridges, right? Very heavy metal blocks are used. So the blocks may be like appearing pretty solid and good from outside, right? But inside it may have a cavity. Let us say there is a cavity built over here. Now it is not visible from outside. No air pocket or some kind of cavity. So that will affect the strength of the block. Over the year it may get corroded, water seeps in there. So the strength will be compromised, right? So since from outside it appears okay, so what is the way to figure out whether it is okay to be used or not? So what is done is ultrasound waves are sent from you. Okay, and you have ultrasound detector on the other side. So if these waves are reaching the detector, then there is no problem. There is no problem. Right? But wherever there is a problem, the wave will be reflected back. Okay? So this is how it can be detected. Detector will detect the intensity of ultrasound wave, input ultrasound wave, and the intensity of received ultrasound wave on the other side is not same. So this is not okay. Understood? Wherever there is gravity, it will just reflect it back. Okay? If it is uniform, then the medium is same. There is a change of medium. If you change, this thing will happen. Okay? So this is industrial. Then you have a lot of medical applications. So let's look at medical applications of ultrasound wave. So ultrasound wave are used for imaging of internal organs such as gallbladder, liver, kidney, uterus. Okay, so all this imaging can be done. Like a patient can sit and the ultrasound detector will be placed on the body. Okay, it will send the ultrasound waves inside and the internal organs will reflect it. That reflected wave will be captured and it will be input into computer. Computer will process it and generate the image of the internal organ on the monitor. And the doctor can evaluate it on real-time basis. While the person is sitting live, okay, means he is not unconscious, person is sitting live, and doctor can actually evaluate, okay, the live status of the organs functioning inside. That's one. Also in pregnant females, so the status of fetus, okay, it can be monitored just by sending ultrasound waves and check the status whether the growth of the baby is okay or not. Likewise, when the imaging is done only of heart imaging can also be done using ultrasound waves. Imaging. Okay. So the ultrasound wave can be sent on heart, and the reflected ultrasound wave can be processed, and the image of the heart can be produced on the monitor. So when ultrasound wave is used just for heart imaging, it is called echo. You are using method of reflection of ultrasound. So echo, cardiography. Anything related to heart is termed as cardiography. Okay, so cardiography means heart imaging. Okay, so we are using the technique of echo. Reflected. Echo means reflected sound. So this is all I have to tell you about this chapter, and with this we come to an end of your physics course. So physics part of science is completed. You can do some questions in the remaining time. Right, so we have homework, classwork numericals, homework numericals on page 75. So question 1 to 14 are daily, right, on page 75. Classwork exercise. Can we quickly run through it? Or shall we do the classwork numericals? What do you want? Daily we have done already. Huh? Numericals we do? So, or quickly scan whichever question you want me to in the theory also from 1 to 14. Is there any particular question you want me to help you with? Mostly we have covered and you should be comfortable. Is there anyone who missed sound first lecture? All four were present, right? Okay, ठीक है. So ठीक है, then we can go to the numerical directly because theory we have covered. So do some practice on framing the answers. Just see what kind of questions are there. Okay. It may not be like I have explained, you have understood, but how to produce it on the paper, that may require some practice. So enough questions are given in your volume. Also at the back of the exercise in the book. So do practice them. Okay, let us do numericals. So it is a diagram based question. What is the amplitude in the given wave? 2 centimeters. So straight. Then question 2. A sound wave has frequency 5 Hz and wavelength 20 centimeters. How long will it take to travel 1 kilometer? So this is similar to example 1. Take a look at example 1 or you can do it directly to it. So since speed is equal to distance over time, right? Now this is not an echo problem, mind you. It's not about reflection of sound. So here speed will be distance over time. Okay? So be careful and you are supposed to find time. Therefore time is equal to distance upon. So speed is v. Okay? Use v. D by v. Right? Now what is the formula for speed of sound wave? It is nu into lambda. Frequency into lambda. Now everything is given. You can substitute. What is the distance given? Distance is 1 kilometer. So 1 kilometer is 1000 meter. Is the frequency given? 5 Hz. The wavelength given is 20 centimeter, which is 0.2 meter. So all this conversions you have to carefully do, right? All in SI units, and then you will get correct answer. So what is it? So 5 into 0.2 will be 1. So time is 1000 seconds. 1000 seconds. Okay. You can convert this into meter or 1000 by 60. So 50 by 3. How much is this? Given there 3. Replace it. 60. What is it? So answer is 1000 centimeters. And the first part of the answer is its typographical error. In question 2, you have to find only the time taken to travel a distance of 1 kilometer by the sound wave, and that is 1000 seconds. Okay. Question 3. Is everybody with me on question 2? सबको समझ आया? Okay, now question 3 is an echo problem. So here the formula will be D is equal to by 2. क्योंकि यहाँ पे फॉर्मूला क्या होगा देखो कैसे होगा D is equal to echo का question है 2D आ जाएगा सिर्फ PD है. So therefore D कितना होगा? D into T divided by 2 आ जाएगा. So 85.5 into 3. So 5 256. ठीक है 256 पॉइंट. नेक्स्ट क्वेश्चन ट्राई करो. ठीक है where to use which formula, be careful. You may write in the note. It says echo question. This is a non-echo question. So general formula for velocity. Of course, fourth one. Similar question. So fourth is similar. Since fourth is absolutely same formula. Here also you have to find the distance of the cliff. What is it? D into dy 2I measure. Okay. So what is it? So D is 3. Speed is 350. You want that rules and you put in by 2. Okay. This is number 1, 2. 525. Okay. Question 4 is. Then you have question 5. It is the depth of the sea. Again, distance. Same formula. Okay. So I'm just writing the formula. You can check it yourself. Depth also you will find by echo only. Send and then return down. Next, question 6. Question 6 is, what is given? Given new frequency is equal to 100 Hz. Then what is the time period find out? So what is the relation between time period and frequency? Since time period is equal to 1 by frequency, reciprocal, right? This is 1 by 100 second, which is 0.0. If you remember the formula, relation between time period and frequency is this. They are reciprocal of each other. Okay, this is a diagram question. So what is the? So the answers are not telling up to the question. The answers are written here and there. Okay. Question 6 answer is given below the wave diagram. Okay, and 3062. What is 3062 meter? This might be depth of sea. And 525 is answer to question 4. So the answers are misplaced. So just be careful. And question number 7. So what is in the diagram? The diagram is like this. So this is displacement and distance. So this distance is given to you as 6 meter. 6 meter. What are you supposed to find? Find the wavelength and frequency. Right? What is given? The wave is traveling with speed. The speed is 3 meter per second. Okay? And you have to find frequency. And also find wavelength from the diagram. So what is the wavelength? You know that wavelength is which distance? This distance is wavelength. Right? From here. So these are 3 equal parts, right? 6 by 3 is 2. So 2 plus 2. So wavelength should be 2 plus 2 equal to 4 meter. Correct? You know what is wavelength? By definition, it is one cycle. So this is 1.5 cycle. So 1.5 cycle distance covered is 6 meter. Okay? So that's how you arrive at 4 meter. So that's wavelength. What about frequency? Frequency is velocity upon lambda. Right? Because you know this formula says V is equal to nu lambda. So nu will be V by lambda. So what is V? V given is 3. Lambda is 4. Right? So this is 0.75 hertz. Okay? So answer 4 meter and 0.7 hertz. That is the answer to question number 7 and it is displayed in question number 8. So let's do question number 8 now. So longitudinal wave is produced on a slinky. So slinky is like children play with the spring kind of a thing. Have you seen that? The spring just, okay, and you can see it is compression and rarefaction. That's called slinky. So longitudinal wave is produced on a slinky. The wave travels at 50 centimeter per second. And each particle vibrates with a frequency of 10 hertz. Okay. So V is given and frequency is given. What is the minimum separation between two adjacent positions where the slinky is most compressed? So distance between two adjacent compression is nothing but wavelength. So you have to find wavelength. So use this formula again. So what is it? So question 8 says V is equal to lambda is equal to V by this. V given in the question is 50 centimeter per second. So in meter per second, it will be 0.5 meter per second. Okay. This is since V is equal to 50 centimeter per second. This is equal to 0.5 meter per second. And what is the frequency given? 10 hertz. So it will be 0.05 meter or 5 centimeter. So it is 5 centimeter, and this answer is not given to you, right? This answer is not given here. Now the last question, question number 9. Chalo, you do it. Question number 9. Is it an echo question or without echo? Without echo. So which formula of speed? Yes. Just do the proper unit conversion. Everything in SI units, you'll get the answer. So it will become 6.06 mark. There is 6.06. Six point zero six. Okay, now you have on page 77 more numericals for practice. So now you practice yourself. If you have any question, you can ask me. You have 4-5 minutes remaining. Okay, so you can just do it yourself. So, okay, children, I take your leave and I wish you all the best. Happy studies. Huh? So, happy studying. Okay, and in case you feel you need my help, just you let me know. Okay, let her know and help you. So, we'll be there to see you till your exam. So, don't worry. Okay, all right. So, all the best.
अच्छा थोड़ा अच्छा रास्ता रास्ता है